I needed a better pen holder for my A1 printer. Instead of just waiting or wasting filament on poor quality prints from MakerWorld, I decided to waste filament on my own design and see if it would work. My goal was to build a pen holder with only 1 degree of freedom along the z-axis. That way the pen can adjust to uneven surfaces and still produce precise, consistent prints. Based on what I learned in my last video, I added a few more requirements. The design should need little or no support and use an optimized print orientation. No screws should drive directly into plastic, and the holder should not damage the pen or print head. It also needs to keep the pen centered and steady, no matter its size, and work with different pens without using tape. With these requirements in mind, I found some good ideas on MakerWorld and combined them into 2 main parts. First is the front cover, which snaps onto the print head with tension clips on one side and holds 2 8mm rods on the other. Because of this design, I could not print it flat, so I printed it vertically on its side and added a rib mesh inside for strength. To avoid needing supports for the rest of the design, I removed the external fillets and angled all overhangs underneath to 45 degrees. I changed the round holes to teardrop shapes and left the rod holders open at the top. Still, 2 of the 4 rod holders needed support, so I turned those overhangs into bridges with 2 custom support tabs. These tabs are 0.6mm thick, making them easy to remove along the layer lines. The second part has 2 slots for linear bearings on the sides and a central clamp. The clamp is a single split collar with ribs for alignment and relief. I made a custom knurled thumb knob that holds a captive M4 screw, which threads into a hex nut inside the clamp. This setup lets the holder grip thick pens up to 15.5mm wide, and adapters with matching ribs help it fit smaller pens and keep them centered. In the slicer, I use the 0.12mm preset. To improve bridges, I set the bridge flow to 1.5 and lowered the bridge speed to 10mm per second. I also increased the wall count to 4 for strengths, except on the front cover. This choice comes down to our bridges. In the slicer, the orange line represents the outer wall, with a line width of 0.42mm, and the yellow line represents the inner wall, with a line width of 0.45mm. Then there are the light blue bridge lines. Since my custom support is only 0.6mm thick, even 2 walls would leave the bridge printed in mid-air and probably fail. With 3 or 4 walls, it would almost certainly fail. I use Cool Plate Super Tack, so I do not need any brims. This time I printed with tough PLA, which is pretty strong and quite transparent. That transparency lets me spot potential failures early in the print. If you look closely, you can see dark lines where the model is hollow. I focused so much on bridges that I missed those thin sections. When I checked the slicer, I saw the model was too thin there to fit the inner wall. So I will need to redesign it. Still, I finished the print to see what else might go wrong. The bridges did not fail completely, but they could not properly adhere to the supports. Printing the adapter in place was a mistake. I eventually separated it, but I won't do that again next time. The nut fits a bit too loosely, but the screw fits perfectly. Although the knurled knob needs a more prominent texture. Removing the custom support turned out to be both easy and satisfying. The fit for the rods and bearings is too loose as well. Adding clearance to those holes was a mistake, so I will reduce it for the next version. I plan to seal the bottom holes to prevent the bearings and rods from slipping out if the spring pressure is too high. Then I checked whether it would snap onto the print head, but it didn't. Because my measurements were slightly off. Here is a closer look at the print quality and failed bridges. Since the model was not working, I decided to test its strengths. I applied a good amount of pressure, and although it bent, it did not break. Even with those mistakes, I stayed optimistic. The concept was good, but needed refinement. I fixed everything I mentioned earlier, so I will not go into every detail. To fix the tension clips that were in the wrong position, I downloaded a front cover with good reviews from MakerWorld and copied its shape and placement. I also added a custom support to the bottom tension clips. To fix the wall that was too thin, I moved the bearings and rods further from the front cover. This made the rod holders longer, so I chamfered them to shorten the bridges. I also made the support thicker. The printing profile is almost the same, but I switched to concentric patterns since my models have many round shapes. I used 3 walls because none of the models are thick enough for 4, and I used 2 walls for the front cover again. I printed this late in the day, fell asleep, and checked the results only the next morning. It looked like all my fixes worked. The supports were a bit harder to remove, but still possible. The bridges were not perfect, but they looked pretty clean. The only thing left was to check if it would snap onto the print head. And it did not. Again. The bottom clips were a bit too long. I sanded them down and snapped the part on later, but the model still needed fixing. Before printing the front cover with the fixed bottom clips again, I ran some bridge tests to see what was happening. I tested flow rates of 1.4, 1.5 and 1.6 at a speed of 10 mm per second, plus one test with the default settings. I made the support 1.3 mm for all these versions. The adjusted settings were an improvement over the defaults, but slight changes in flow rate made no noticeable difference, and increasing the support thickness did little to help. I think the only thing keeping my bridges from being perfect is long, thin support, which may bend slightly during printing. But I'm okay with that, so I moved on. I printed a front cover again without changing the print profile, and the print turned out even better. The only variable was the front cover's position. It was printed in the center because it was the sole element on the build plate. Now that the front cover snaps into place, the last step was to create adapters for different pens. I was a bit too confident and printed all the first versions at once. But not everything fit because some pens are tapered and the plastic is too firm to bend for the thinnest ones. I fixed the most problematic adapters and the clamping mechanism by adding deeper relief ribs and printing them with an Arachne type wall generator to avoid random hollow spaces. Once everything worked, I printed the rest of the adapters. With that done, I could assemble the holder and was finally ready to test it. The bigger the offset between your nozzle and marker tip, the more pressure is put on the springs and snapping clips during homing. This is when the pen can slide up, or the clips could snap off. I didn't want to screw the adapter to the print head or use longer springs and rods since that would make it heavier, so the trade-off here is accuracy in settings and pen positioning. Here's, in my opinion, the easiest and most convenient way to position the pen in this holder for the best results. Move your print head to the home position so the nozzle touches the build plate and then move slightly up. At this point, attach your pen so it touches the build plate. Now you can print. With this setup, your Z-draw should be between 6 and 8. I used 7 for most prints. For a big pen, use 6. For thick markers, I used 7, but 8 might be better. A lower Z-draw value means more pressure. My test showed that a single sheet of paper on a SuperTech build plate is less likely to slide, resulting in a more precise drawing. However, you are more likely to see build plate's texture in your lines, especially with a ball pen. I reprinted on the same piece of paper to check whether the pen would follow the same path exactly, and it did. With a ball pen, I also noted that the pen itself does not shift, but the refill inside does, which can affect precision. I repeated the process with all the pens. .5 to 0.7 liners with a 7 Z-draw value were the best for precision. Even pencil prints were good enough. Tapered pens like Sharpies or Centro pens can slip, so make sure the screw is tightened securely. The adapters for tapered pens are not symmetrical. Use the teardrop-shaped hole as a guide for the correct orientation. When positioning a pencil, align it so the flat side rests against the color split, not an edge. If it is misaligned, the pencil will slip. Let's look at the final prints. They are consistent and accurate. There is still slight shifting on long curves, but you probably will not notice it. Overall, the holder meets the requirements I set at the start of the video, and I think it is good enough. It is worth mentioning that the 3D Plotter app got an update that solves most of the issues I mentioned in my previous video. With my new holder and the improved software, I plan to make another video showing a real use case for this plotter setup. The holder with 6 adapters is available on MakerWorld for just one like under this video. Use it at your own risk. There was also a triangular adapter for brush pens, but it is unusable because the printer damages the soft brush tip during homing. I also had a last-second idea for a 60-degree adapter, but it is not very good yet. I will make something better later. I even have a better idea, but I need a break from this project for now. Thank you for watching and see you in another video.